Welcome to the fourth section, which covers instrument reprocessing, or the returning of instruments to their pre-use condition preparatory to further use. In this section, we'll be looking at the general principles of reprocessing, particularly of sensitive instruments. Then we'll look at ultrasonic cleaning, and finally, we'll have a particular focus on the reprocessing of endoscopes. As before, you'll have the opportunity to test your knowledge with 8 multi-choice questions before moving on to the next section. All items for disinfection should first be cleaned and rinsed, but instruments need special care. All instruments need pre-cleaning and should be submerged in the cleaning solution while scrubbing to remove all traces of previous use. It is important to use demineralized or purified water in the dilution and rinsing processes, especially for expensive endoscopic instruments. We'll take a more detailed look at endoscopes later in this section. The reason we use demineralized or purified water is because tap water contains chloride ions, which can corrode the surfaces and interior areas of these instruments. Chloride ion corrosion can be a principal cause of instrument failure. Do not use surgical hand scrub solutions or any kind of liquid soaps. The rinsing qualities of these are inferior to specialist instrument detergents and may lead to residue buildup in delicate moving parts with resultant expensive damage. There are 2 main types of instrument cleaners: enzymatic detergents and specialist enzyme products. Broadly speaking, detergent products work by breaking into and reducing molecules to smaller molecules, thus penetrating the soilage, breaking it down and allowing it to be rinsed away. The addition of enzymes means it can break down further the difficult proteins that arise from body fluid contact during use. Reprozyme enzymatic instrument cleaning products from Medimark Scientific are based on triple enzymes to digest organic material left on and inside instruments after the specialist cleaning process. They are specially formulated as instrument cleaners. Ultrasonic cleaning is a process that uses ultrasound to create minuscule cavitation bubbles in a container of cleaning solution. These produce high forces on soilage particles lodged to the surface and inside channels of an instrument. These soilages are more effectively broken down by the combination of cavitation and the chemical activity of the cleaning solution. Minute fissures and recesses are penetrated by the process in a manner that cannot be replicated by simply soaking in an immersion tank. Cleaning will typically take between 10 and 30 minutes, dependent on load and perceived soilage. The ultrasonic bath must itself be kept spotlessly clean. It cannot be relied upon to clean itself by the process of shared action while in use for instrument cleaning, and needs to be separately cleaned to remove and inhibit buildup of biofilms. Biofilms are composed from any group of microorganisms in which cells stick together and often adhere to a surface. If they grow to sufficient levels, they can overwhelm the cleaning compounds used in the ultrasonic machine and transfer to instruments, thereby increasing risk. Minimize biofilm growth by using enzymatic-based detergents to clean the ultrasonic tank, followed by rinsing thoroughly and an application of disinfectants such as Anagene from Medimark Scientific. This process should be employed after every change of cleaning solution and a record kept as part of the SOP. As mentioned earlier, endoscopes and other internal examination instruments present a high risk of cross-contamination due to their close contact with body fluids and pathogens. It is therefore imperative to make sure these are fully cleaned and disinfected before reuse. Improper endoscope cleaning presents a high risk of transmission of gastrointestinal infection. For example, strangles caused by Streptococcus equi is serious and affects horses treated with a respiratory tract endoscope which may be infected with the bacterium. Flexible endoscopes present special risks of damage if submitted to heat sterilization. The lens areas are particularly vulnerable. The repair bill for a heat-damaged scope can be so expensive that the risk is not worth it. Cold sterilization is therefore recommended. Start with a large bowl of filtered or purified water. with a mix of Reprozyme manual enzymatic instrument and equipment cleaner. Immerse the endoscope completely. Wash in detail with disposable, non-lint wipes and cotton buds. After straightening the flexible tip of the endoscope, use the special cleaning brush supplied with the instrument to pass through the biopsy port, moving it very slowly. Contact the manufacturer if an obstruction is felt. When the endoscope emerges from the tip, wash it thoroughly and pull back to the beginning. Repeat the process until you are certain it is clean inside. Some body fluids are harder to release from surfaces than others. Where an endoscope has been in contact with mucosa, there may be stubborn traces remaining. A special process is required to brush clean the forward channel beneath the suction button. The same applies to the suction unit area. See the manufacturer's instructions for details. With the biopsy port cap and button reconnected, connect the suction system to its port and turn on, or use a large syringe and tubing. Press the button and pass the enzymatic solution through until the solution starts to fill the aspirator bottle or the syringe. Rinse everything using a fresh bowl of purified water. Press the button as before to pass the rinse water through the channels. Disinfect with Reprodis HLD4 solution to maker's dilution by pressing the button and passing the solution through the endoscope until it emerges into the aspirator bottle or syringe. Leave the instrument in the solution for 10 minutes, then rinse as previously with a fresh bowl of purified water. The air-water channel should be drained. When all processes are complete and the instrument is externally dried, the instrument can be tested for image quality and stored in its special place under manufacturer's recommended conditions. If the same level of diligence is exercised in the decontamination of all instruments used in surgery and internal examination, the risks of cross-contamination will be greatly reduced. Some organisms pose higher risk factors than those more often found in practice. Bovine spongiform encephalopathy is caused by prions. These organisms are extremely resistant and a very special sterilization process must be engaged. Another major risk would be any patient suffering a Group 4 condition. Thankfully, the likelihood of encountering BSE and Group 4 conditions is rare, but if it does occur, then specialist infection control consultancy should be sought. We've now reached the end of section 4, covering instrument reprocessing. You can now test your knowledge by taking the quiz. As before, just click on the quiz button below, and if you get any wrong, you can always review this video to refresh your memory and try again. You can then move on to section 5, which covers barrier hygiene.